Good morning. How are you? Thrilled to be here. Chile is a wonderful country, and we've enjoyed the hospitality of all the folks that are here. So when we talk about renewable energy, and we talk about Black & Veatch, probably best to talk about and introduce you to who we are, and then kind of talk a little bit about how we got to where we are in the power industry and why renewables are really part of what's going on, and then some key considerations about involving renewables and what you do. So Black & Veatch, and for some of you, you may not know who we are. We're really an infrastructure company. We are equipment neutral. So for us, it really doesn't matter which technology, which company. We're about engineering. We have extensive business in the energy, in the water, the telecom. We have management consulting. And we also do government services, which is primarily with the United States government, federal type systems. For the last 30 years, we've really been involved in Chile in the desalination side. But when you look at energy, we've been involved in power generation services. We've been involved with renewables. We've been involved with microgrids. When you look at water, it includes hydro. And then telecom, we do both public and private networks associated with that. And management consulting really is that independent engineering. Folks know us from due diligence, from working with financial institutions, to help give them bankability on many different projects. But really think of us as an engineering company, a consulting company. We procure things, and we also construct. So we're interested in all the different things that you're doing. So let's talk about the 100-year story of energy that really starts in the early 20th century. And Chile is really interesting in it because you really started in the late 1800s. As you turn the century, you're involved in hydro here, and a very effective use of it in the mining, and also for the population around the mines. But we really have this power conversion technology that's happening here. We've got turbines, we've got steam engines, we've got hydro. And then as we start to look at energy, energy really turns to the different fuels. What's really going to fuel it? And so we look at coal, we look at oil, and of course with hydro we have the water. And when we look at transporting it, it's really important to understand that there's this battle between Tesla and Edison, AC/DC, who wins? But as we go forward with it, it really comes down to the technology, the conversion technology, the economics of the fuel that you're dealing with, and then how you're going to transport it. And so that really becomes electricity to the masses. So the early advancements really sit back and say, hey, internal combustion engines, steam boilers, they're going to grow in size. And we have this from the 1920s to the 1970s. We really look at this expansion. And to really make it very personal, it's going from 80 homes to 800,000 homes per power generating facility. And then we have this AC decision, alternating current, that sits back and says, hey, it's no longer a distributed model. It's becoming a centralized model, and it's going to really go from neighborhoods to cities and regions and the points of use. So once we hit the 70s, we've got a real emergence in technology that goes forward. And what happened in the United States and happened throughout the world kind of rippled. And that was we had an energy crisis that came in with the oil system, the oil crisis, and we had an environmental movement that happened almost coincidentally. And all of a sudden, we have this birth of renewable energy. We've got windmills. We've got solar installations. And I graduated in 1983 as an electrical engineer, and I remember dealing with solar panels. And I remember they were expensive. I remember that, gee, it was an interesting idea. I remember wind was sort of, people were starting to mess with it. And so now when we look at the 1980s and 2000s, energy storage becomes something that's really valuable. So what we're going to do is we're looking at the technical solutions that really turn to practical applications. So when we look at today, and this isn't a subway map or a train map, it kind of looks like one of those crazy things somebody might design. What it's really showing is the efficiencies associated with photovoltaics. And if you look to the far left, you'll see 1975. When you look to the right, you'll see 2015. If you look at the upper half, those are really government and special laboratory type inventions or things that happen that they're getting better efficiencies. But when you go about midway, that really becomes a commercially viable photovoltaics, which are going forward. So you've got a real increase in efficiency. But this is what's driven the business, this pricing curve right here. So take 1977 through 2013. Look at that drop. Look at that drop in price. When you're looking at $76 a watt down to 74 cents a watt, all of a sudden we've got something that makes financial sense. Because it really doesn't matter if it's a good idea if you can't make money with it, if you can't put it into a system and you can't use it. We can't complete the conversation about photovoltaics and renewables without talking about energy storage. I've heard it over and over at this conference, and that is the intermittency, and we like to call it the variable energy of solar and renewables, is a problem for baseload. It's a problem for dispatching in just greater metropolitan areas and in regions. We see it in California. California is dealing with a lot of the same issues that you guys are dealing with, and that is how to take this variable energy resource and employ it in a way that really makes sense. So storage technologies become extremely important because when you look at it, it's that time-shifting capability or that demand response capability. Yes, up in the north of Chile, up by the mines, you have a level load. But as you move into the central area, you have what we call the duck curve, to where things start high, fairly high in the morning, they drop off as people go to work, and it comes back in the evening, it goes up. And there's two ways of looking at this, pump and hydro storage. And that's not necessarily new as much as it is specific. And part of the specificity is having to have water and having elevation. Well, you're uniquely positioned in Chile for that. And I know there's some restrictions associated with that, but it's something that should be considered. And then battery storage. Battery storage is the next great thing coming forward. We work with battery storage people on a daily basis. We have relationships with Tesla. We work with other folks. So we understand that right now the big bet is lithium ion. And it's such a big bet that Elon Musk is putting a 5 gigawatt plant in Reno, Nevada. 5 gigawatts a year he's going to produce in batteries. Not to be outdone, the Chinese are going to do a 35 gigawatt plant over in China with Samsung. So what we have are people making big bets. But unlike the efficiencies associated with photovoltaics, battery storage is really coming down to chemistries. So you had manufacturing technology driving photovoltaics. You've got a chance for a real sea change with the chemistry side of battery storage. So there are other types of chemistries, and you can see them listed, but one of the really hidden ones is a flow battery. And so as we go through this, it'll be extremely interesting as this dynamic world changes to see what the winners and the losers are in this. But you can be assured that there will be advances. So this is somewhat of a complex slide, so I'm going to take some time just to kind of go through it with you. And as you look along the y-axis going up, each one of these are technologies for integrating. Remember, that's the key thing. It's not just about storage. It's about integrating different variable energy resources into a practical application. So the height of this bar graph is the current cost to implement. So what does it cost dollar-wise? The shaded area is the maturity of the technology. And so if we look at storage, it's not a very mature technology. But the width is the potential impact. And so this tells the story of why battery storage is really important, because its potential impact on variable energy resources, such as solar and such as wind, is huge. So when you keep an eye out for what's going forward, those are the things that really become very, very important. And I hope that I explained this well enough for you guys to grasp what this means in the industry going forward. Okay, so we have technical things that have to be done, and we have social things that need to be done. And when you look at society, society draws opinion, and it will eventually tell us where we're going forward and tell us where the investments will be. Limit us to some perspective, move us forward to other perspective. But this is a Gallup poll that was done in 2013. And essentially what it's asking is where should we put more emphasis? Now, it's from the US, but our research tells us that the Chileans feel very much the same, the general public. And one of the things is when you look at solar, wind, and natural gas are all seen as very attractive to the general public. And what we'll see is at the bottom is coal really is not seen as attractive and that we shouldn't have further investments in it. So when you sit back and feel like as a coal producer, as somebody who likes coal, that steady baseline, that you're getting picked on, please don't feel you're getting picked on, because there's a whole bunch of us at Black & Veatch that spent years servicing coal, building coal plants. But these things are trends that we see very much going forward. And as we look at where the US is, what we see is we're now having to integrate. I mean, California at this point, and I spend a lot of time there, has just put forward that they're going to have 1.3 gigawatts of energy storage to support the renewable energy. The renewable energy standard for California is going to go from 30% to 50%. So that means half the time you're going to have renewable energy as part of the usable energy mix, not the capacity, but the usable energy mix. So while this may not be stuff we want to see, it may not be comfortable, it's really a leading indicator of where we're going. So let's make the case for renewables. Okay, so we're going to break this down into just three real fundamental questions. Do I have a proven technology? Right? Nobody wants to invest in a first of a kind. Nobody wants an experimental car, right? Wheels might fall off. So we got to have a proven technology because we're business people. Do I have a quality fuel source? Well, that's one of the things that Chile is fantastic if we can figure out technology and business-wise how to do it. You've got the second best sun in the world here. And every other fuel source that you're bringing in, you're having to bring in. You don't have natural resources in the terms of fuel besides your sun and your wind. You're dealing with a great disadvantage even though you have great opportunities. And then can we get the power when and where it needs to be? These are these challenges we see with your transmission structure. These are the challenges we see with the different types of load curves depending upon your grid areas, the privatization of some transmission lines, and also the need for an active independent system operator to run your transmission or regional transmission authority. So when we look at it, these three fundamental questions really beg to us. Now, the technical considerations are very interesting because at Black & Veatch, while we're very technical and we're very engineers, we have to be business people too, and we have to look at how we meet those business objectives. So one thing is really understanding that true power requirement. To think that you're going to replace your baseline fossil generation with renewables is folly. It's not going to happen. But it can be part of the solution. And so integration is going to be a big deal. How do we work with things? In other words, can part of a desalination plant, as we understand more water is going to be needed for the mine processes to go forward. How do we start to couple in things that make sense? Do you really understand the technologies you're going to make an investment in? That's really, really important because you're going to make an investment CapEx-wise in these things. Integration. So we call them variable energy resources and distributed generation. So when we look at the integration of those things, that's very, very important. You're not going to find a single point. There's not what we would call a silver bullet that takes care of everything. Available land resources. Well, that's one thing that doesn't seem to be a problem from what I can tell up at the mining areas. But really what you're looking at with PV solar, just so you get a perspective, is about 1 megawatt per 5 acres. So it can be a little less depending on spacing and other things, and as efficiencies get better, and they will continue to get better, but that's what you're looking at. And then understanding mining and the process and the needs associated with the mining industry. So part of our philosophy at Black & Veatch is to hire experts in those fields, integrate them into our business. Because it's not just about us selling a technology to you, It's about us understanding. And we think that's something that's really needed in this area right now. So in the business area, overcoming that paradigm of intermittency. Wow, that's a big one, right? I wish we had an answer for that. We'd close the conference off and we do really well. But we've got to understand that these energy resources are variable, and how do we do it? The employing of energy storage, different things like that. The core understanding of the risk to using solar versus offsetting traditional. Well, we may not want to think about it, but we have risk with our traditional generation. We've got LNG prices that fluctuate. We've got coal. We've got gas prices from we're importing these different things. So putting $1 to it's important and understanding what that means. And then evaluating all the options. One of the resounding themes I've heard over and over again is, how do I get financing? How do I get PPAs? How do I not go build something and have it worth zero with the output of it? Getting rid of that spot price situation. So as we put these things together, as we work with clients here, one of the things we're looking at is, how do we couple these things together? Finally, I'd like to show you some core competencies that we actively work on and that are part of who we are. And so desalinizations, we're currently working with that in Chile. Solar PV, we actually do consulting, we do detailed design, and we do engineering, procurement, and construction. Battery storage, we're actively part of that. Hydro, this is a picture of a pump storage in South Africa. Transmission and distribution, we're very active in that, and traditional gas. So we think these different things are core pieces of the puzzle that needs to go together to solve the Chilean process. Thank you very much.